Hello and welcome to another video tutorial in ANSYS Workbench and ANSYS Mechanical. In this particular video I am going to show you how to compute the angle of twist in a structure. The same principles can be applied to any structure. In this example I'll simply use a circular torsion bar and compare the solutions to hand calculations. We will also compute the shear stress and the equivalent stress and see how they compare. So after creating the geometry and space claim, when we open up mechanical, it will import, and you can see we have one geometry, one body, and it's made out of structural steel, so we know the properties. What we need to do is come to model and click on model with the left click and then right click on it, and we could insert a connection. Since I've already done that, we have our connections group down here, so I'll left click on connections, then right click, and I will insert a joint. So I scroll over and down to insert a joint. The default gives me this spherical joint right here, so now I'm going to click on that, and down here I see the details of this joint. The first thing I want to change is the body to body connection type. I want my answers to be relative to the ground. So looking for a rotational angle, I'm going to select body to ground. Now I don't want to use a fixed type, so I want to click the drop down here and actually come down and use a general type of connection. Now what I need to do is all of these translations and rotations are set to fixed, and I need to change all of them to be free. So I'll click on them, click the drop down, and change them to be free, and make sure that I get the rotations as free all. So now I'm to this point. The rest of these settings here are okay, except for the behavior, and I need to click on that and change it from rigid to deformable for my reference. Now I need to scope and select the face that I want to put this joint on and where I want to know the angle of twist. So I'll click on the yellow no selection, and then this has come up based on my joint. And so to get back to my model, I need to come down here and click on geometry, and that will bring up my geometry, and I can come up to face select, select this face, come over to scoping and click apply, and I now have my one face on my solid body. The other thing that I need to change now is the behavior here, and I need to change that behavior from rigid to deformable as well. Now to kind of see the rest of the list, I can come here and click and slide this window up a little bit. Now I can see the entire details for my general joint. And I just double check. I got a body to ground. I got a type general. I've got all my conditions set here as free. I have a deformable behavior. I come down and I have my one face selected, and I have under mobile behavior deformable selected as well. So that's what my joint needs to look like. So now I will come over to mesh, and I'll click on mesh, and I actually want to change the resolution here. I've changed it to 7 so that I have a high resolution, and I'll go ahead and click mesh and then generate. This will take just a second because that will be a dense mesh. The boundary conditions that I need to apply, I'll come here to static structural, and I have a fixed support on this end, and then on the free end I'm going to put a moment. So I click on moment. I have it on the one face. I have a moment of 1,000 inch-pounds about the Z axis, and you can see that the torque is being applied to the free end. So I have my settings there as I need them. Now I can come to solution, and I've added a total deformation on all bodies. I've added an equivalent stress on all bodies, and I've added a maximum shear stress on all bodies. I want to make sure that I can get the angle of twist, so I need to add the joint. So if I come to solution and right click on it, I can insert and come over, and I'm going to insert a probe, and I'm going to come over and insert a joint probe so that it will tell me the information at the joint that I have on the end where I want to know the angle of twist. I'll come over to boundary condition. I only have one boundary condition in my model, so I choose that boundary condition. The other thing I need to change in this model is I am not looking for a total force result type, but I'm looking for a rotation. So I'll click on the box, click the drop down, and you actually have to scroll down to get to rotation. So I'll have a relative rotation that I will enter as as my result type. I now have everything set here. I can just double check my model. These are all the outputs I want. I have my fixed support, my applied load, and I have my joint, so I'm ready to hit solve. Now that my model is solved, I can click on the results. I can see the total deformation. That makes sense that there's 0 back here, and it increases as I come to the free end. I can look at the equivalent stress, and over here I can see that the magnitude of the equivalent stress is 138.32. I can also see that up on my color scale up here. I can look at the maximum shear stress. My maximum shear is 79.86. 79.86. Now I can look at my joint probe, and coming over here I can see that the relative rotation for my joint probe is 4.9 e to the minus 3. And that's the relative rotation about the z-axis. If I do the hand calculations, I have done those, and these are the results that I have attained with the hand calculations. So back to equivalent stress, we had 138, and that's the same value that we were able to compute with the hand calculations. So that verifies the results. Hopefully this video has been helpful in showing you how to compute the angle of twist using ANSYS Mechanical.